Hi, and welcome to Monitoring and Improving Your Big Data Pipelines. My name is Andrea Foegler. I'm a developer on the Cloud Dataflow team, and today we're really going to deep dive into the tools and resources that are available to you to monitor and investigate and improve your big data pipelines that are running in Google Cloud. We're going to focus primarily on Cloud Dataflow pipelines, but the second half of the talk will be looking at Stackdriver, and a lot of the tools and resources you see there are available for all of the Google Platform services. So a lot of that information will be relevant sort of across the board, regardless of what services you're working with. So a quick overview of our agenda. We're going to start with just what are Cloud Dataflow pipelines. What kind of things are we talking about monitoring? What are they doing? What's the service doing that we need to be watching for? And then we're going to look at actually building Cloud Dataflow pipelines. And so why is that relevant to a monitoring talk? When we think about monitoring, a lot of times what we think about is that sort of last operational step when we have a service or pipeline that we're running. And so we've got everything ready, we're going to push it out, and we need to just make sure that our service is healthy and everything's performing as expected. And if not, then somebody is getting alerted or notified that it's going wrong. So we're definitely going to look at that part. That's an important part of monitoring. But a lot of the tools and resources we're going to look at are really useful much earlier in the development process than that. So we're going to talk kind of through what that process looks like. So when we get to those tools and resources, you can see how to use them when we're actually in the middle of that development process. Then we're going to go into the Dataflow UI itself. There's a lot of great information there, and it's all presented very pipeline-centric. So what I mean by that is you write your Dataflow using the Dataflow SDK, and we sort of translate that into a graph that you then see in the Dataflow UI. And so when you're navigating in there and looking at your metrics and looking at your data, you're really doing it through that visualization. You click, you navigate by descending into the hierarchical view. You're looking kind of at one step at a time in the way that you authored that pipeline. And so then when we move into the Stackdriver and our Stackdriver integration, you're going to see a very different view, and it's going to be very timeline-centric instead of pipeline-centric. And so what you're going to find is that looking at the behavior and analyzing what's going on from that time view is going to be very different from what you see when you're looking at the pipeline view. Navigation there is also going to happen via search instead of sort of clicking through a graphical interface. So between these two, you have a very powerful set of tools depending on kind of what stage of your development you're in and what kind of problem you're looking into or what kind of data you're looking for. So specifically kind of diving into what we're talking about for the Stackdriver integration. So Dataflow is integrated with Stackdriver logging, and the main thing you get from Stackdriver logging is when you wrote your pipeline and you're coding it up, you start writing debug messages and whatnot when you're doing this on your local computer, but it's also really useful for when things start happening in your service that you don't expect. So you log lines about it, and this is where you go to find them. Well, if you have to walk in there and look for it and search every time, that's useful. I mean, it is your data. You can go find it. But one of the great things you get by doing that is the ability to create metrics based on the log data that you're putting out. So you can write log lines, write a search for particular things of interest that are happening in the logs, and then you can create a metric that actually lets you track that, alert on it, chart how it's behaving over time, which is a really powerful way to monitor your service. So the next thing we're going to look at is kind of the highlight of this talk, and this is our new beta integration of Dataflow metrics into Stackdriver monitoring. So the monitoring data, the particular metrics we're exporting are exactly the same ones you actually see in the Dataflow UI, but from the Dataflow UI, you kind of get a snapshot. You get to see just what's going on right now. And by exporting them to Stackdriver, we get to see a whole historical view. And since the Stackdriver UI isn't so specific to one pipeline, one instance, you can actually compare things between jobs. You compare different stages of your pipeline to each other. You can compare different metrics to each other. So it's a much different view of those same metrics and provides a lot of power in investigating your pipeline. And the last thing we're going to look at is the GCE metrics that you can look at for the instances that are actually doing the work on your job. And so there are a handful of metrics that are available for all GCE instances. And then if you happen to be a Stackdriver premium customer, then there are agent-based metrics, which provide a really rich picture of what's going on each instance. And Dataflow exports those for all the instances that are running your pipeline. And we're going to take a look at those as well. So what is a Dataflow pipeline? And what does the Dataflow service do? So a Dataflow pipeline is basically, it's a graph you construct using the SDK by saying, do this operation, then after that, do this operation, then after that, do this operation, and you build up a graph. And then you take that graph, you say, hey, Cloud Dataflow service, execute this graph for me. The Dataflow service then constructs an execution plan to run that graph. It then brings up the GC instances to run it, and takes care of, say, if the Dataflow service may notice that your job would benefit from more parallelization. So then it may actually bring up more instances for you, break up the work a little more when everything's done. If you cancel the job, or if the job just finishes, or if for some reason the job fails, it'll shut all those down, clean everything up for you. So this fits into Google Cloud, kind of like what you see here. You can actually see Cloud Dataflow up there in a couple different places. And so you have services in the cloud that pull your data into the cloud. PubSub is maybe one of the most common ones that gets integrated with Dataflow. And so Dataflow becomes like your processing layer for that data once you get it into the cloud. So whether you're uploading files into storage, or however you got that data, it then gets pulled into Dataflow. Dataflow does the processing and then pushes it usually out to some other cloud product, like maybe a BigQuery table, but maybe out to another PubSub topic where you're going to do further processing on it. So one thing to look at here is that this is not an uncommon setup, and there are an awful lot of little icons on that page. And so when you think about monitoring, you may have a lot of different services interacting. They all have their own quotas. They all have potential holdups and timing and issues. And when you think about monitoring these things, that becomes a little bit daunting. And so when we're talking about Stackdriver, one of the fun things that I think is that you can kind of use this unified metric model to think about monitoring all these services at the same time. And it feels to me like it brings down the complexity of this when you can think about all these metrics, get them all from the same place, use the same services to analyze them and notify on them. All right, so we've kind of looked at Dataflow pipelines and the Dataflow service from like the 10,000-foot view. You've probably heard about the Apache Beam model. The export of kind of the Dataflow, making it open source, this execution model that we've been using in Dataflow. And so what that is it's a programming model that the goal is to make some very complex operations very easy, and to make it so that you don't have to worry about the parts that you shouldn't have to worry about, and you only have to worry about kind of the core logic that you're trying to execute. So like we said, that the GCE instances, it brings all those up. All this execution stuff, you don't want to think about that when you're writing your Dataflow pipelines. So this is true in Dataflow. The whole Apache Beam model kind of handles abstracting away that execution. It abstracts away the parallelization. So a lot of the operations you want to do that need to be parallelized, you don't want to be responsible for when to parallelize, when to split. That's stuff that's all built into the model. And then the last thing is all your reading and writing. One of the most complex things you can do in these big pipelines is just the RPCs to connect to different things, pull in the data, make sure it comes in, make sure you don't lose data, make sure you don't duplicate data. And all that's sort of built in and hidden in the model too, so you just get to focus on the actual logic that you're trying to do. So these are just a handful of the common types of operations that you'll see happening in Dataflow pipelines. So handling events by event time rather than the time that they get into the service is a really tricky problem and something like everybody wants to do. So you have clients all over the place that are uploading data into your service. Some of them are going to go offline sometimes. Some of them are on really slow networks. And so they're arriving all the time, all over the place. And you want your service to process those events by the time that they were created, not by the time they got into your service. So the Beam model kind of abstracts that into this notion of event time so that you can handle processing them by event time and not have to worry about when the data is actually getting into the service. Another thing that you might see is you have a lot of data coming in and it's getting corrupted, and you're not even sure what to do with it, because who knows what happens to your data as it's going across the wire. And so you kind of want the ability to say, hey, this is a bad one. I just want to filter it out, send it down some other pipeline, and let somebody worry about that thing later. This embarrassingly parallel processing is kind of this notion of you want to get aggregate statistics on your data. And sometimes you'll want that by geographical area, and sometimes you'll want that by user or by session. And as soon as you start to want that sort of aggregated data, all of a sudden you have this issue of everything needs to be loaded in memory. You need to have everything present at the same time. And so you need to sort everything and organize it. And so being able to do that without having to worry about it, so that all that parallelization of handling that sorting and aggregating processing is all abstracted away in the model as well. And as I mentioned, the I/O connectors, because that is just always one of the challenging things is your RPCs, your connections, your reading and your writing, and make sure that that stuff is all flowing. You don't have to worry about any of that. So the Dataflow SDK then is an implementation of this model. And so it has all these connectors built in, does all of this, and it's designed to run in the Dataflow service. And so that actually comes with a runner that lets you run locally. So you can execute your Dataflow actually sitting on your box and running on your box and accessing your local machine, your local file system. And then you can say, hey, now I'm ready to launch this thing and run it in the Dataflow service. And so this is what the Dataflow service is providing you. All right, so this process of developing a pipeline. So there are kind of 3 different phases you go through when you're developing. It's not necessarily like you move from phase 1 to phase 2 to phase 3 and you're done, but you're sort of always operating in one of these 3 phases. And so, the most productive one is your local desktop. So you're coding on your local desktop. If you're writing in Java, you've got IntelliJ up or Eclipse or whatever environment you usually program in. And you pull in the SDK libraries, and you do your programming, and you run locally, and you're pulling up test data sources off your local file system. You're using your debuggers to see what's going on. So this is your really fast iteration time. It's where you're going to have the best visibility. There aren't a whole lot of tools that we provide because you have a lot of tools on your desktop for doing this. And then after that, you kind of have your pipeline doing what you generally want it to do. Then this is where you move into remote iteration. So you're going to push this out to the cloud. You're going to run it out there. You're going to start looking at your job in the Dataflow UI. You're going to really focus on a couple different things. One, now you're actually connecting to all of these other services and sources. Are those connections working? You're probably running with a lot more data. When you run with more data, is your answer even correct? Are you still getting the correct output? And lastly, did it scale like you wanted it to? And so this is really where you start to explore your scalability. When more data came in, did it scale like you expected? If you were to run with more workers, did it scale as you expected? And so you're going to play around a lot of this, and this is kind of the time where all of these tools are going to come in, because you can do a lot of neat comparisons. If I run with this many workers, what happened? When I ran with this, what happened? And so we're going to look a lot at what you'll do there. When you do see issues here, you kind of end up going back to local development, come up with a test case that shows the issue before going in, because it's pretty tough to actually debug in the surface. We try and give you a lot of data, but it's still hard to get the specifics of what's going on. And then the last one is that standard, what everybody thinks of as monitoring, where you really need operational stability. And so this is where you want to set up your notifications. This is where you want to make sure that you have everything you need monitored in a way that, if there is a problem, you're sure there's a problem, and hopefully you're not paging, everybody every 2 minutes because you can't tell the difference between your data varying or there being an issue in a network somewhere and your service kind of flailing. And so you need kind of the right set of metrics to handle what you need and make sure everything is caught, but not letting so many things through that you can't tell what's going on. All right, can we switch to the demo? Awesome. All right, so this is start of the Dataflow UI. This is sort of where you're coming to first. What you see on the left-hand side here are all of the job names for the jobs. So I started to clean this up or think about moving to something, and I thought this is actually kind of useful. This is sort of what it looks like. This is what you end up looking like. So you can see on the left-hand side, there are a handful of different names that are being iterated through, and those are the different pipelines that I'm working with. If you see on the right-hand side, there's a totally unique identifier over there. So every time you execute something, that one has to change. That's your unique identifier. When you're in the Dataflow UI, you're really working with that unique identifier. When you're in Stackdriver, you're actually almost completely working with the name. And that's because if you were going to try and monitor or chart, it doesn't do any good to use the unique identifier that happened 3 weeks ago. You want to use the process that you're running every day at noon that you called process logs. You want that. Not Tuesday's iteration that you now have to go pull up a new chart or something for Wednesday's iteration. So you can see on the left, if you name your pipelines, this is my sell to you that you should name your pipelines. I did not early on. And so then the service just names one for you. So you end up with these unique identifiers like you see here on the bottom. Those are they're basically just a second unique ID. So you can use them. But if you provide the names, you get a lot more coherency in the data that you'll look at in Stackdriver. So quickly, what you just get from here, all of your running jobs will always float to the top. So anything that you're interested in seeing running, you'll see that up there without having to go too deep. And then when things have failed, they tend to show up with these big red exclamation points. So it's pretty easy to find those as well. So like I said, the Dataflow UI is going to give you this very pipeline-centric view. And so what this is really just a visual translation of your pipeline. And so when you first get to this page, what you see is the highest level set of transforms in your pipeline being drawn out. So this one's still fairly large, but not unmanageable. And so what do I mean by the highest level transforms? So each of those boxes, when I say transform, this is really just an operation. And each one of these boxes is an operation that you plugged in when you were writing your pipeline in the SDK. So this basically looks like you create a pipeline object and you say, apply a transform, apply a transform. And what happens is every time you say that, you get a new box in the graph. And the connection, the line in between any two of those boxes is the data that's being passed from one operation into the next one. And you can provide the names so that this makes a little more sense. If you don't provide one, it's usually the class name that you gave. And so these transforms can do any number of things. So the ones at the top of your graph are usually reads. They're usually reading in data from some source. The ones at the bottom of your graph usually are writing data out. These transforms, there are ones for flattening your data. So if you have data coming in from a lot of different places, you can merge it all into one big collection. There are transforms for partitioning your data if you have data from, say, different regions that needs to go to different places. There are transforms for doing that parallel sort, for doing the aggregations, like we talked about earlier. And so most of these are, all those ones I just mentioned, those are built into the SDK. And you just apply them sort of straight up, and you parameterize them a little bit. So you may say, I want you to filter out some things if they meet this condition. So you just pass in a condition. So you have all these transforms to work with that are pre-built and just ready for you to parameterize a little. So where those don't work, there's a transform called pardo, a parallel do function. So that transform is in there for you, and that lets you completely overwrite the function that's going to happen on each element that's in your collection. So if you want to do something like, imagine you have in here a user visit coming in, and you need to parse the URL out of that, then you would write a little thing that would take one user visit log entry in there, it would parse out the URL and would output the URL, and ultimately that set of URLs that came out would be the input collection to the next transform. So that is, that's what we say, like those are, I think I'd call them functional transforms. They're the ones that are actually doing operations. Then there's kind of this other class that I'm going to call composite transforms. And they're here purely for organizational purposes. They're kind of like for your organizational sanity, and then for reusability and maintainability as well. So using them doesn't change what your pipeline does at all. Your pipeline still does exactly the same thing. But when you're looking at this, so I'll show you what happens if you don't think in terms of these composite transforms. So you can tell what the composite transforms are because they have that little V. That's like an expanding arrow. So this is what this would look like if you didn't have any. These don't have much. But as you get down to here, what this pipeline would look like if none of this stuff was expanded. So you can start to see, this one I don't think does anything, how much harder this gets to reason about. There's no logical unit. Every single operation that happens is kind of sitting there. And if you wanted to be able to look at it and go, gosh, is the problem in where I'm reading in my data or where I'm doing the group by key and the aggregation, or is the problem when I'm writing? And you'd have to go through and look at every single one of these boxes, and some of these things get to be thousands of boxes big. You'd have a really tough time. And so when you start to organize them, then that hierarchy can make it a lot easier to walk through and look at your data. So I'm going to reload this so that we close all those back up. All right, let's see. So when you look at any one of these, you can click on it, and you get the word step form here should just be considered a synonym for transform. So if you're in a composite transform, you are going to see just the input collection data. So here's the name of the input collection, the output. There's no input collection on a read. The output collection. This is like my favorite new feature. When you hover over the name over here, do you see it turning blue on the graph there? So if all of your transforms have one output, this isn't all that exciting. But some transforms will have 20, 30 outputs. And when you're trying to look at this data and understand kind of which one is which and what the downstream transform is, this can be super helpful. And this just showed up a couple weeks ago, so I love it. Elements added, so it's counting for every collection that's in this pipeline. It's counting how many elements there. When you see the estimated size, it's estimated because calculating size on a lot of different objects is a really slow operation, and we don't want to shove that into your pipeline. So we sample. We take an average of the sampling, and then we multiply it by the number of elements. So if your elements are pretty much all the same size, that's a really accurate estimate. If your objects are all over the place, your mileage may vary. The execution time that you're seeing here is a roll-up of all of the transforms that are in that composite. So I don't think this one has anything else. But like this one, for example, when you're looking at the data for this top-level transform, you're basically just seeing the sum of all the transforms. So this is where having those composite transforms where you can look over your graph and kind of see the logical units becomes a lot faster and easier to reason about. So this one's a Pardu. So this one's a function that someone wrote the function that gets operated, that is operated on each element in the input collection. And so you get a lot of information over here. You get to see exactly what class name is doing that operation, so that can make it easy to go back into your code. And let's see. Then your input, this one actually has an input collection, so you can see the input data as well. Let's get to an actual group by key. So I'm pulling this one up. You're going to come across glitches in the UI, not entirely uncommon. This shows a couple of them. Most of them are easy to work around. They're kind of difficult for us. So this whole process of running the execution plan kind of means your job doesn't actually run like the graph that you're seeing on the screen. So when we're trying to map a lot of these metrics back so that they look like the pipeline that you actually submitted, some things get a little tough, like flattens, for example, which don't actually end up anywhere in the process. So they're always empty. They never have any information in them because they're not actually running as flattens. It doesn't mean anything. The data is all accounted for. The time is all accounted for. We just didn't run anything called a flatten, so we don't associate any data with it. When you click on a group by key, you get a couple extra pieces of information there over on the side. Most importantly, you get the bytes read and the bytes written. Since most group by keys are actually storing your data on disk until they get all the data for a particular key and ready to process it, this is often one of the biggest performance issues that you'll find in your pipelines. And so knowing exactly what that byte count looks like, if you're kind of watching your pipeline run and it usually takes 6 hours and you want to see how many bytes it's written so far. So this is updating while your job is running. So you can say, well, I know it usually picks up 54 gig, and right now it's only got 22, and it's already been running the normal length of time, so you know at least where the holdup is happening. So this one's in here just as a special group by key thing, just because that's very often the performance issue you're looking into. I think that's most of it for step. Let's go back and look at the job level data. So if you click anywhere that's not on a step, you get the job data back. It was also here. This is where we started when we brought up this page. If this job was not finished, you would have the option to cancel your pipeline right here, which is pretty useful. All the rest of this data is just kind of the definition of your job. I think this is fabulous. So if the job was still running and there were a certain number of workers still operating, you would see it here. The reason that that number was there, you would see that here. So what this graph is showing, the blue line is showing you actually how many workers are doing the work for your job right at that time. The green one is showing you how many the Dataflow service would like to have working, but may not be able to, either because it's hitting quota issues, trying to bring up new GCE instances, or maybe the GCE instances for some reason are just really slow coming up. That's the difference in the time that you see there, is really just the time it takes to bring up the GCE instances. And I have seen some other reasons. Right now I can't think of what any of them are. But it's a really great display of exactly how many workers are working. And then you can actually bring that up here and see some more of the rationale for what was happening. Here, nothing went wrong, and it happened all very quickly. But a lot of times in here, you'll see we were trying to do this, but it didn't happen, and here's why we think it didn't happen. So that's some really neat data for investigating what's going on with your job. These are your resource metrics. So all the ones that say current, if the job was running, you would actually see values there. All the rest of them are sort of the cumulative resources that your job used. So how much CPU time did you use? How much memory did you use? How much persistent disk time did you use? So this is the cumulative resource usage for your job. So this will be really neat when we get over into Stackdriver, and you can both chart this over time, but also compare it between different runs. These are the custom counters you can add to the SDK. So there's a notion called aggregator in the current Dataflow SDK. I think that'll change slightly with our first implementation of Apache Beam, but you'll always have the ability to define your own metrics. And that's what these are. And so here you see the current value. You can name them whatever you want, and then they're always prefixed with whatever the transform was in which you defined them. So if you wanted to count how many URLs you saw that ended in .edu, then you could have a counter that was your edu counter. Every time you saw an element come through that ended in .edu, you would then increment that counter, and you could see that value here. So we do export these as well to Stackdriver. So here you can see the final data. But in Stackdriver, you can actually see how that data changed over time. So if you think of good metrics to create and track how your job is doing, then you're able to visualize those and record and alert on those as well. So if you remember those names, invalid rank and invalid visit, we'll take a look at those when we get to Stackdriver. And here are the pipeline options. These are just what you passed in when you started the job. But it turns out if you're running 10 or 15 different jobs with 10 or 15 different set of options, it can be really hard to remember which file, what files this one ran in, or how you had configured the workers, how you had configured the auto scaling. And so here's where you can see how you actually ran that job if you're trying to figure out why it did what it did, why it didn't auto scale to some particular number. Yeah. So here we have logs. Before we look, I'm going to go back here real quick and go to one of these ones that failed. So if there were errors in the job, there's a really clear indicator right here. It's a yellow triangle if there are warnings, and you get this exclamation point if there are errors. So if you click on this guy, you can see what the error was. So this was me first putting together these data flows and running them here. And so I got all these errors. So if I want to know what went on, I know my data flow failed. I can see that. I can see what it kind of started. So this is the first place you look, especially if you actually got an error here. Sometimes you won't, but if you do. So here I can say, it didn't get the file size. All right, standard stack trace, got to go down. All right, here we go. So couldn't get the file size because it actually wasn't allowed to access the file it was trying to read. So first kind of step in debugging, if you have errors here, your quota errors will usually show up here. Basic access errors will usually show up here, so you don't have to go any further than this to find these type of errors. All right, let's go back to the one we were looking at. And these have been very intermittently not showing up, and I'm not sure why. I will try one more time here. If not, we may just not have the job logs on this one. I think we're going to give up on that because it has been pretty intermittent today. So normally you would see the logs. The logs here aren't terribly interesting unless there's an error. Mostly this is just telling you what the service is doing. The only interesting logs here really were the auto-scaling ones, but now you have that great graphical representation, so you don't really need to look at the logs for it. Mostly it's just telling you, we're starting your job, we brought up some workers, we're trying to bring up some more workers, we're shutting down your workers, we're done with your job. Here's the easiest way to access the worker logs. So these are the ones going to Stackdriver logging. So we'll jump over there now. So there are a handful of logs that the Dataflow SDK and some of our code will export here. And you'll see those here. The chance that this is useful is relatively low, but they might be. But this is also where you find any logging that you added. So that's what's most interesting here. So I happened to add, oops. Oh, I can't spell. I added a catastrophe log. So this is the log that I'm emitting with just like logger.warn in the SDK code definition for this pipeline. And so here's that. That's great. I saw it. It's not a very interesting log. But what I can do with this is this create metric button. Can you see this up here on the top? If you click on that, you get this metric name. The easiest thing here is to change this down just to Dataflow step rather than a particular step, because you want this to work for all of your data flows, not just that particular one. And then you give this guy a name. So let's see. Catastro. And if you want, you can limit this to, you see all these log types here. Chances are you will never ever look at them. The worker logs are the ones where your logs end up, so you can limit to that if you want. You could also say I only want to see the warnings because these are all going to be warnings. Then we create a metric. Doesn't look like anything interesting happened, but we jump over here. So logs-based metric have two different flavors, I guess. The first ones here, these system metrics, these are always here. So you have these automatically without you having to set anything up, which means if you just want to have an alert that says, error logs are showing up in my logs based on some sort of GCE instance or a Dataflow job, printing them there. You can create metrics on that without having to go through the process that I just went through. because things like log entry count are already there, and you can filter by error. And I'll show you how to do that when we get there. And then the next set are these user-defined ones. So you can see I already have user catastrophe down there. The reason I have that is so that we can actually look at data in Stackdriver, because it doesn't retroactively search your logs. So only if we were creating new log messages that matched that metric would we see the data show up in Stackdriver. So I wanted to make sure we had data there. So I'm not going to use the one I just created. I'm going to use the other one, which is exactly the same. I just happened to create it before I ran the last few runs of the job. And so what you can do from here is create alert for metric. And this is when we jump into Stackdriver. And so this is a logs metric, which is why it shows up here under the resource type. So this is the same interface you would see, kind of regardless of what sort of thing you were trying to set an alert up for. This is the metric. We want to see it against a Dataflow job. So every time you see resource, you're just going to look for Dataflow job on here when you're looking for anything you created against something that was output from Dataflow. So anytime this metric was above, let's say, 3 for 5 minutes, you can filter by region. If you're outputting a similar type thing for different job names, you could filter by different jobs. We only have it in this one. And it's only showing up in the worker logs. So the way this works, these can be a little tricky because they actually have to match already before you can create this. So you can't say an alert if this were to ever happen. You actually had to have had it happen, or else these drop-downs aren't populated, and then you can't create the metric. So that's a little unfortunate. So you do have to force it to happen once before you can easily create a log on it. But it is kind of neat because you get, as you're building this metric, this is what this metric has looked like. So since I created it, however long ago I created it, this is what we have been seeing with that metric. So you kind of get to see that, and it gives you a good idea now that I can see what it's doing, I can decide how do I want to set my threshold. Oh, if it goes over 5,000 for more than a minute, or depending on how it's behaving. So you kind of get this preview at the bottom, set up your metric. And then let's see, save the condition. There's not really, here is where you can add notification information. So if when this alert goes off, I think I set it to go off if there are 2, so it's clearly going to go off just like every time there was a spike there. You can have it send you an email. You can have it do any number of things. So this is where you get your fun alerting functionality. Nothing else here is particularly interesting. I actually already have one of these. Oh, I need to delete that guy. And this will take you to your alerting violations page. So here, if you're looking at what are all the things potentially going wrong anywhere in my service, you can come here and see all of them. And so you can see here on the one, so I tacked on that 2 there on the one I just created, because I already had this one, because again, I wanted to have it have already created some of these alerts so that you could take a look without having to wait the 35 minutes for the job to run. So you can see that we have resolved 4 of these already. So if we go into here, there are no more open because it's only looking back a certain period of time, and this job isn't running anymore. So it's not continuing to alert. And these alerts do self-resolve. Sometimes that might not be what you want, so we've actually put a lot of effort into trying to come up with metric definitions that do what you want them to do. I think that'll be an ongoing game. So the way that I happen to set these metrics up, they are only going to alert if in the last minute or 5 minutes you saw some number of these errors, which means as soon as the job finishes, you're not seeing it, and it does resolve. So if you do get used to if you are going to try and use this, these metrics for alerting, you do have to sort of understand the Stackdriver model, because the Stackdriver model is really assumes you're monitoring a service. And we're not really a service. You're running a pipeline, and you're wanting to monitor your pipeline execution. And so you'll find that everything in Stackdriver is always kind of looking backward for now if the process isn't still running, it doesn't think that it matters anymore. And the alerts are kind of designed that, well, clearly the service recovered if you're not seeing the errors anymore, because it doesn't understand that, well, that thing actually just failed, and we still want to go back and look at it. So we have some metrics to make that a little easier. It does mean you have to be careful when you're thinking about the alerts, though. So let's see. So that's alerting. From here, we can go ahead and look. So when we did this, we just set an alert up on a metric. It's actually a metric. So we can actually go and look at that. And so this tool, this metric explorer up here, was pretty recently added. At the kind of the point where you're going, what metrics do I have available? What do I want to see? What can I use to monitor my job? What does this data look like? If I wanted to add alerts on this, if I wanted to add this to a dashboard, what kind of parameters do I want to put on that? So that's what this is really great for. It's just kind of getting a general sense of what metrics you have available, how to access them, what they look like. Once you kind of have that, you won't be in here too much. But one of the things we can look at, so we know we just created this metric called catastrophe. So we can come over and look at it here. So this is where that notion of you're monitoring a service kind of comes in. A lot of times you'll do this and you'll see nothing. It so happens we're still within an hour of the last time I ran this job. So you can see just on the far left-hand side, it always comes up as an hour. So if you ran this job 3 hours ago, it's going to say, I don't have any data. It does have the data. You just have to tell the graph to look back further. So we're kind of working, since this is just getting into Stackdriver, and our model is pretty different from what they're used to working with. We're trying to work with them on how to make the graphing be a little more conducive to the standard data flow jobs. But here you can just click on 6 hours and you see the data. You just have to remember that. For me, it's always a little bit of a panic when I see that, no data. So this is that metric that I just created a handful of hours ago to count those logs. So this is a logging metric you can see there. Everything here that starts with custom data flow, so there have been a bunch of things that have run against this project. Every time a job runs that has one of these aggregators in it, you get a custom metric, and they show up under this custom/data flow. And so the ones that we created were invalid visit and invalid rank. Those are the ones we saw on the right-hand side when we were looking at the data flow UI. And so I can look at those too. So I've run this job 6-7 times since this morning. This is how these things behaved. Now, I just have a little counter in there that basically says every time you process 10,000 elements, increment. So it looks the same for every single job. But it's a great way to say, how do I look at, since you can run everything as the same name too, you can compare what it's doing from run to run, you can look at it historically. We could pull up a week's worth of data here if we wanted. We only have a day's worth, but we could. So now we can see these, we know what it kind of looks like, we can decide what we want to do with that. Quick scan of what other data we have here. So these are the data flow metrics. These ones that actually start with data flow /. So we have those element count metrics that we saw on the right-hand side and the estimated byte count. These are those over time. Elapsed time is really just measuring that the job is still running, but it gives you an easy way to alert on things like this job is taking way longer than I'm used to it taking. And I think this was pretty much every service here publishes something like an elapsed time. So you can pull that up. Now, when we're looking in here, we have nothing filtering. So every job I've run, remember there were a whole bunch of them on that list page earlier on, they're all here. This isn't just the batch ones that I've run. So it can get a little confusing looking at things in this view, and filtering gets a little tricky. In here, it'll be fine once we move on. So you can see system lag, which we'll talk about when we look at a streaming job. These are all of the all those resource metrics, so you can see what your resource usage is over time. And then these are those logging metrics that we have. So like I said, this is a good first place to kind of just play around and see what you've got. There's not a whole lot else to do in here, though. So for that, there are a couple different places you can enter. So these are the pages for the individual resource types. And so we'll look at Dataflow ones, but you can also look at things like PubSub. So these are all the topics that have ever been created. And so, and one of the jobs, the streaming job that's running, actually brings up a second pipeline that writes to PubSub, and then the other one reads from PubSub. So you can actually see that on here, and if you're reading from PubSub, you can see the information on that subscription. So it gives you a way to say, yes, I'm thinking about Dataflow, but I can also look at how all the other services are operating as well. So this is the PubSub dashboard. Most of the dashboards look kind of like this. These are the incidences that we've seen, of alerts that you've created against this sort of thing, and then the one or two graphs they think are most useful. So here's the Dataflow one. I haven't figured out the ordering of the jobs on this page yet, but they have filtering, so you don't actually have to be able to find things, and they sort. So when it first comes up, your job may not be where you expect it to be, but you can sort by anything that you'd like, any of these fields, to find the job that you want, or you can just filter. So if I'm looking for the ones called next batch, they're right here. And so from here, I can see those incidents again. So these are the logging ones, because it knew that those logs were created against Dataflow logs. And so it knew that was a Dataflow resource that log metric was created against. So when you go to your Dataflow resources page, you're actually going to see those instances. So it becomes kind of a place where you can find all the data in one place. So those are all the alerts that have gone off. You can also see, so you can see how this starts to look a little odd with the 1 hour back. So these are the element counts for all of the collections for each run. And so I can come down here, and so there's an element count for each transform, or collection in between the transforms. And so you can see where those are. You hover over them down here, you can see. So here, every run looks the same because there's no difference in any of the data. I'm just running the same job. But you could see for each iteration of the job, how did the data differ? How did the different collections show up differently? And so then you can also see, so these are the ones that kind of, what's the resource cost of your job? And so that's what you see over here. And so these are each iteration. So the one thing I did vary between different runs of this job are how many workers I assigned to it. So you can see the difference in how much CPU it used, how much memory it used, based on the number of workers that are in there. So this is what kind of the default dashboard. So you kind of get this automatically without doing anything. You run a Dataflow job, all this stuff shows up, you click on it, you get here. Now, let's say what I was doing with this particular job is I wanted to know what the effect of running with a bunch of different workers is. This kind of lets me see, but it doesn't make it super obvious to correlate the information unless I remember for sure how many workers I used on each one. And so this is where you can start to create your own dashboard that's pulling out the data that you want. And so you come over here to dashboards here on the left, and then we can create our own dashboard. And then I can add a chart. And let's say I want to add a Dataflow job. And what I want to look at is, let's say, how many CPUs it's using at any given time. And you do have to filter in here by what job that you want. This is a global dashboard at this point. So if you only want to look at ones that were called next batch demo, I think I have that there. Again, the 1 hour. So this is what the different number of CPUs look like during the execution of several different iterations of this job. And then I can add another chart. That shows let's say the elapsed time of the job. Again, filter by name. And again, this is the name of your job. And so now you can start to see how you would build these up and be able to correlate. So you can even like drag these lines across. So I want to say, okay, this job ended up taking took 10.5 minutes. And I can see over on the left-hand side that it used 80 CPU. These metrics are in CPU, not in workers. So if you're using a 2 CPU worker or a 4 CPU worker, you're going to see the CPU count here, not the worker count. So when you see 80, I either ran it with 40 or 20, depending on whether I had it configured for 2 or 4, I'm not sure. So this is where you get some really great stuff for really looking at a bunch of iterations of your job and comparing the metrics as you're going through. And I think this is kind of really what you lose out on the Dataflow UI. The Dataflow UI really lets you see the context of the graph, but it doesn't let you see over time or between jobs very well. So you get a lot here. So what you saw me sorting on was one particular job, and it's that particular Dataflow job and just the Dataflow name, which works. But you'll find that a lot of times what you'll actually want is if I run, let's say, 4 Dataflows throughout the day on every 12-hour increment, I might call them, dash noon, dash 6, dash midnight, dash 6 a.m. or something. And so I'll have slightly different ones. And in that case, you want to start using groups because you don't necessarily want to think about them as different things. You want to alert on them the same. You want to look at the data and compare it all the same. And so you can create a group. Groups they're pretty much prefix searches. So when you name your jobs, as long as you name them with matching prefixes, you can turn these things into a group. So you just give this guy a name. This is my batch one. Excuse me. Now, the interesting thing here is that I'm not necessarily talking about a Dataflow job. This resource could be anything. So this is going to make it really easy for me now to start building dashboards that pull in anything that we happen to name with this name in it. So save the group. Now the group exists, and now you can basically use that group just like the name of a job. You can filter everything on that rather than on the name. So I, in the interest of time, created one for the streaming job. Actually, before we look at that really quickly, let's look at the streaming job in the default. So the big thing you get out of here for a streaming job that you didn't get out of batch is that system lag. So the system lag is measuring, this is kind of a global measurement, so it's not ideal, but it's a really good quick measure of what's hanging around in your pipeline and not getting all the way through it. So your system lag is something came in, and we haven't finished processing it yet. So how long is it taking to is it getting stuck somewhere? So this is what's hanging out in your system and not making it all the way through. So it's a really good measure of your system getting stuck or getting slow. And since your job is not going to fail, if it's a streaming job, really under any condition, you need something. So this is the best measure we have. For batch jobs, you can usually just use the fact that the job failed, which there's also a metric for. But system lag is your big one when you're looking at a streaming job. So that's what you get over here. The rest of the metrics are pretty much the same. But I wanted you to see a sample of a dashboard that you might put together for monitoring these jobs. So these are all filtered down to that group. And this group is basically anything that had next dash streaming on it, streaming. So for starters, in this upper left-hand corner, you can see this is actually an agent-based metric. So for the job, unfortunately, these are only accessible while the job is still running. Something we're trying to work on. But for the time being, since these are services, and this is how services get measured in Stackdriver, they don't exist anymore when they don't exist, so these metrics do disappear. The streaming job is still running. So the agent-based metrics, the left-hand one, is telling you what the memory usage is. And so you only get that from the agents, and so that is the Stackdriver premium one. The middle one, the CPU usage, you get for any GCE. instance, and you can see how. Let's see if you pull this guy up. These are all the different instances that are running this because we prefix search. So we'll have a better experience here eventually. But you can, because I said that my group was defined by next-streaming, then I'm able to pull in the CPUs on that group. I'm able to pull in the pub sub that actually gets spun up on that group. And so I can look at any type of resource that I happen to have connected to this thing as long as the naming conventions work. So here are all the instances that are running on that job and what the CPU usage looks like. Here's the system lag, which again is probably the primary thing you're using. And so you can see here the lag is, so the way that this generator is operating, the way that the thing that's pushing all the data onto PubSub is it basically blasts and then backs off, blasts and backs off. And so you can see the lag builds up when it just can't process a whole lot of the data. And then it recovers, and the next blast comes in. You can tell that because here's the PubSub subscription. So you can see how that aligns with the lag. And so it's really, this is the super powerful thing that lets you start to see what is the timing of the different behaviors and be able to use that to sort of root cause the issues that you're seeing. So you can see here, oh, here's what my PubSub subscription is. It spiked, tons of stuff got put on. My backlog started to get pretty bad. Data fell off. It recovers, and everything looks good. Here is that cumulative metric that's recording the resource usage. So if you just kind of want to make sure your jobs aren't getting too expensive, you have an easy way to look at that there. And then basic element count, just kind of depending on whether or not that's a useful metric here, you might have your custom metrics instead as sort of a gauge of the data. That's interesting. I am far more out of time than I expected, so I think that I will stop there with that demo. So can we go back to the slides, please? All right, so just really quickly to wrap up. So go and check it out. So we just kind of put this out there. We've had a few people working with it. We're trying to work with it, but seeing what people are using, I happen to think it's a really great way to learn about the Dataflow system. You can see a lot about what's going on and investigate. You just have so much data now. Well, when's it doing this and when's it doing that? So you can use it to learn about Dataflow, but also to really play around with your own pipelines and see what's going on. Ask questions on Stack Overflow. We watch those, we answer, and it tells us what you're looking at. And so that gives us the feedback to build and improve this stuff. We love to hear from everybody. And so lastly, we're talking about Apache Beam, talking about Dataflow SDK here. So there are 2 talks tomorrow. So if you want to know more about those, you should definitely check those out.